Hello friends, welcome to the another tutorial of basic electronics module. In this particular chapter or session, we are going to learn about the transistors. That this revolutionized invention of transistors, how they changed the world and entire industries. So in this particular session, we are going to learn the basic concepts of transistors, like what is their history, what are transistors, their making, their working principle, different types of transistors, and also the different applications and applications area.
So let's first see what are transistors. So transistor is a semiconductor device and the invention of transistor is so revolutionary. The invention of a transistor has been a revolutionary till date. This has changed the entire industry and you can say world also. And impact of transistor is so good in electronics and so many other areas. So these are the widely used and also you can say these are the semiconductor devices which are widely manufactured, means millions and trillions of transistors are made uh, made by industries and as well as they are used in the wide range of applications. So they are the invention of you can say late 19th century, which has changed the entire world. So this particular chapter is divided into four different types. In the first part, you'll see the basic introduction to transistor. Then in the second type, we will see the different types of transistors and the working of some of them. In the third part, we will see the different characteristics such as input, output, and current transfer characteristics of transistors. In the fourth and last session or part, we will see applications, advantages, and disadvantages of the transistors. So let's first start with the basics of transistor. So this is how typical one of the transistors looks like. There are so many different transistors and available in the market. So what is a transistor? So a transistor is a semiconductor device used to amplify or switch electrical signals and power. So a transistor is a device basically which is used, so it is a semiconductor device and it has its two main function. Firstly, it amplifies signals and also they are used as a switching device to turn circuits, to turn on and off the circuits connected to it. It is one of the basic building blocks of modern electronics. It is composed of semiconductor materials, usually with at least three terminals of for connection to an electronic circuit. Means it generally comes with three terminals which connects with the external electronic circuit. A voltage or current applied to one pair of the transistor's terminals controls the current through another pair of terminals. Means the voltage or current applied to one of the pair of transistor terminals, it is able to control the current through another pair of terminals. So you can say these are the current or voltage controlled devices, because the controlled means output power can be higher than the controlling input power. A transistor can amplify a signal. So this is how they amplify a signal. Now let's just see the simplified explanation. So you can compare a typical transistor with a tap. A tap we use in our house to from which your water flows. So you can compare them with a tap. So transistor is analogous to a faucet. Turning faucet's control knob means this. Turning this knob alters the flow rate of water coming from the faucet. Means by controlling this knob you can control the rate of water flowing through this output area. So a small current or voltage means a small change in here can vary output here in terms of you can say water. Some change means some minor movement in anticlockwise or clockwise direction can change a higher amount of water. it can change a higher amount of output water coming out from this. So similarly, transistors are a device which controls the current, or you can say when applied, when you apply some current or voltage at this base or center pin of transistor, can alter, or you can say amplify, or control the current through these two terminals. So current in this particular pin can control the current or can amplify the current in the circuit, or you can say in output. Now let's just see the manufacturing of transistors. Now a smaller low power transistors are, this kind of transistors are enclosed with resin case to protect the internal parts. Now this kind of transistor means particularly some low power transistor or small transistors, they are enclosed in the resin case. This outer section is called resin case. So they are enclosed in this resin case in order to protect the internal parts, or you can say the internal area of this transistor. So these are nothing but a resin case. But in in case of higher power transistors, so when there are transistors used in higher power circuits, so they have partially, or you can say partly, metal case. This is a metal case and this is a resin case. So there is a partly metal case which is used to help remove the heat which is generated, which is generated during the operation, and it helps to compensate, or you can say to minimize the heat, as this higher power can damage the component over time. So this metal case is connected or attached to a heat sink, which is used to minimize the heat, or in the some of the devices such as in DC power supply, the MOSFETs are connected to a larger heat sink in order to minimize the heat, or and protect the devices from overcurrent or damage area. So these are the two different types. In this, there is only a resin case because they are operated at a comparatively lower voltage, and in higher voltage application, they comes with a metal case partially. Now this was about the basic of transistors and how they are manufactured. But let's see second part of our session, which is the different types of transistors. So in this section, we will see the different types of transistors and working of them. So a transistor is nothing but it is a three-lead semiconductor device which acts, or which uses as an electrically controlled switch, means you can turn on or off the external circuits connected to it through an electric signal, giving a signal to its base pin. You can control the external or main circuit which is connected to it, and also you can use it as a current amplifier, means it is capable of amplifying signals. So it does what? So main two functions of a transistor is you can use it as a switch to turn on or off the circuit connected to it, and also it is used to amplify the signals in a particular area. A typical transistor is composed of three layers of semiconductor materials, or more specifically terminals, which helps to make connection to external circuit and carry the current. And these three terminals are namely called as base, collector, and emitter. Now, here are the different types of transistors. So these are the transistors which are divided into two categories according to their construction type. The first is BJT and the another is FET. Now BJT stands for bipolar junction transistor, while FET means field effect transistor. So this is the two main categories into which you can divide transistors. Now this BJT is further classified into two main types, which is NPN and PNP. This is NPN transistor and PNP transistor. And this field effect transistors are further divided into two categories, and which are junction field effect transistor means JFET, and MOSFETs means metal oxide semiconductor field effect transistors. Now these both transistors are further classified in these JEFTs are divided into depletion mode, in which there are two types. One is N channel and another is P channel. But these MOSFETs are divided in two further categories, which are depletion mode and enhancement mode. In depletion mode, similar to this, there are N channel MOSFETs and there are P channel MOSFETs. Also, in enhancement, N channel and P channel. So this is a classification of transistors. So, mainly the transistors are divided into two different types according to their constructions, and which are BJT and FETs. But from constructional difference, you can divide them in three different categories, which is BJT, JEFT, and metal oxide semiconductor field effect transistors. So, first are BJTs. They are further classified in NPN and PNP. Then there are JFETs, in which you have depletion type of transistor, which are N channel and P channel. But in metal oxide or MOSFET, you can say two types and another two types, which are depletion has N channel and P channel, and enhancement type has also N channel and P channel. So these three are the basic, or you can say the different types of transistors. Now let's just first see the BJTs, means bipolar junction transistor. BJT stands for bipolar junction transistor. Now it is a type of transistor that uses both the electrons and electron holes, means majority and minority charge carriers. So bipolar, hence they are named as bipolar, means they are using both majority and minority charge carriers. So it is a combination of two junction diodes and is formed either a thin layer of p-type semiconductor sandwiched between two n-types of semiconductors forming NPN transistor, or a thin layer of n-type of semiconductor sandwiched between two p-type of semiconductors forming PNP transistor. Now this construction produces two PN junction. Now see, in NPN there are two PN junction. One is this and the one is this. Also in PNP transistor there are two PN junction. One is this and one is this. So now this construction produces nothing but two PN junction. A base emitter junction and a base collector junction. And these both junctions are separated by a thin region of semiconductor, which is known as base region. So in BJTs, they are using both electrons and electron holes as a charge carrier. And in this type of transistor, there are two PN junctions, and in between these two junctions, there is a region with region of semiconductor, which is known as base region. Now, these bipolar junction transistors are further classified into PNP transistors and NPN transistors. So, a PNP transistor consists of two crystal diodes which are connected in series. The right side and the left side of diodes are known as collector based diode and emitter based diode, respectively. A small output current and a negative voltage at base, means VB, which is less than VE, allows a much larger current to flow through emitter to collector. So in PNP, the current flows from emitter to collector. And in PNP, as it names, there are two P type of semiconductors, and in between them there is a thin layer of N type of semiconductor. While in NPN transistor, one P type of material is present between two N type of materials. Now this NPN transistor is basically used to amplify weak signals. The NPN transistor is basically used to amplify the weaker signals to strong signal. In NPN transistor, the electrons move from emitter to collector region, resulting in formation of current in the transistor. A small input current and a positive voltage applied at base. At base, the voltage is greater than to voltage at emitter allows a large current from collector to emitter. So in NPN transistor, in the NPN transistor, there is a current flowing collector collector to emitter, and in NPN transistor there is a current flow from emitter to collector. Now, so have as you have seen the two types of BJT transistors. So in both the types, there are three terminals. So in PNP as well as in NPN transistor, there are three different terminals, which are particularly one is base, second is emitter, and the third one is collector. Emitter, base, and collector. These are the three terminals of any PNP or NPN transistor. This is used to activate the transistor, which is a base terminal. So base terminal is always used to activate the transistor. Any voltage or current at this pin can turn on your transistor. So whenever you want to turn on your transistor, you'll have to give any input signal, you can say a voltage or current, to a base pin. Now emitter, it is the positive lead of transistor, so it is known as a positive lead of transistor, while collector is negative lead of transistor. So in this particular section, we are going to mainly learn of the operation and different working of BJT transistors, which are NPN and PNP. So let's just see that how does a transistor works in terms of BJT transistors. So, a transistor can use a small signal applied between one pair of its terminal to control a much larger signal at another pair of terminals. This property is called as gain. It can produce stronger output signal, whether a voltage or current, proportional to a weaker input signal, acting as an amplifier. It can also used as an electrically controlled switch, where the amount of current is determined by the other circuit elements. Now the two main types are PNP and NPN. So this is how your transistor, but typical transistor, looks like. In transistor, as you can see, there is a resin case into which your different internal parts are protected. Now here it is a base pin is always a center pin in either in PNP or NPN transistor. The base pin is one which is in the middle. So the middle pin in NPN or PNP is known as base pin, and to left it is emitter, and to right it is a collector pin. Now the uppermost region is the flat surface, while the lowermost region is curved or C-shaped. Now, this configuration of E and C changes may vary according to the manufacturing of your transistor. So, just refer your transistor script, or you can say data sheet, which comes with a particular transistor. Now, as you can see, these NPN and PNP transistor are so look alike. So you will have to you will have to check whether it is NPN or PNP by checking a number written over onto it. So you can differentiate a transistor just by checking its number written over this resin case. So in PNP or NPN transistor, this is how your transistor schematically represents. Now you will ask that why do we need transistors, right? So as we discussed earlier that the main function of transistor is you can use it as a switch. Either you can use it as a switch, or you can use it as an amplifier. But why do we use transistor, or why do we need transistor? So typically, when a light is powered through a battery, it illuminates bulb. Whenever a light bulb is powered through a battery or some external power source, or you connect a bulb between a battery, two terminals of battery, it just illuminates. And we know that we connect it to a switch to manually turn it on and off. In order to on and off operation, you connect it with a switch. So we can connect a switch to turn it on and off. But this turning on and turning off operation, this particular operation requires a human to manually turn it on and off the switch. But what if we want to automate this task? So in that case, your transistor comes into a picture. So then we can use a transistor by connecting it in a circuit where when there is no current at base, means you can connect a transistor to this switch to this particular light bulb, and you can automate it. But how you can automate that operation? So in order to use a transistor as a switch, so whenever you have connected your transistor with a light bulb and there would be a battery, then if there is no current through base, means if you have not provided a specific amount of current to your base of transistor, then the light bulb connected to it will remains in off condition. But if you connect your transistor's base with some external power source, as soon as the base pin reaches to a particular voltage, it turns on it turns on this light bulb. So whether you can so in order to achieve that, you'll have to connect this with a power source. Now to turn this power source on and off, you can connect a sensor. So through this sensor, the power source turns on, and this turning on will provide a specified amount of current to flow through base. And as soon as your current flows through base, it will turn on the it will turn on the light bulb. And that's how you can use a transistor to switch on an external or main circuit. Typically we need to apply, or we need to give at least of zero point 0.6 to zero point 0.7 volt to the base pin of transistor to turn it on. So as we have discussed earlier, a transistor requires a minimum of zero point 0.6 to zero point 0.7 volt to turn the transistor on. So we have to at least give zero point 0.6 or zero point 0.7 volt to base pin in order to turn on this transistor. Now, as you can see, as you know that whenever you give a particular amount of voltage, so if you give a zero point 0.5 voltage, it will remain in off condition. So the bulb connected to it will also be off. But as soon as the voltage reaches to zero point 0.6, it will turn on the LED. But you can see that LED will not glow at its full efficiency. But and with the increase in the voltage, or you can say input signal, which is your voltage, there will be a change in output. Means at zero point 0.7 volt, it will be glowing. Your bulb will be glowing at its full efficiency. So some change in your input changes output highly. Means smaller change in input changes a high amount of output. And that's how you can see the amplification process. So this current at base and the current at collector, the dividation of collector current and base current gives you current gain, which is nothing but gain. So gain is the collector current divided by base current. Now in NPN transistor emitter, this emitter. In case of NPN transistor, this emitter is always gets to connect with the positive terminal of negative terminal of battery. In NPN means NPN. So also you can see from this picture, I will give you some explanation on the connection. Now this is the schematic representation of PNP and NPN transistor. As we know, in PNP transistor there are two P type of semiconductors, and in between them there is a N type of semiconductor material. And in NPN there is a P type, there is a thin layer of P type semiconductor sandwiched between two N type of semiconductor material. Here is one terminal, here is second terminal, and here is third terminal. Your middle terminal is always known as base. One is emitter and the other one is collector. In PNP transistor, as you can see, emitter and collector are positively charged, or you can say they are positive semiconductor material. So whenever you connect your PNP transistor, you'll have to always connect the emitter side, or you can say emitter terminal, with the positive terminal of battery. So this is P type, hence this positive region will get be connected to the positive terminal of battery. While in case of NPN transistor, the emitter and collector has negative charge, mostly because they are made up of N type of semiconductor material. So this type of semiconductors have their emitter connected always to the negative terminal of battery. So in the NPN transistor, the current flows from or you can say the flow of current is from the positive terminal of battery to through the transistor, and in transistor it flows from base, collector, base, and then emitter. So in this particular NPN type of transistor, the current flows from base to emitter, from base to emitter. And in this type, the current through this emitter is combined from here and also from here. So in NPN type of transistor, the current combines, means it has a higher output, means the output, or you can say the emitter current is more. While in PNP transistor, the current flows from positive terminal of battery to emitter to base. So it goes from positive of the battery through transistor this way. From positive terminal of battery, then it enters to emitter, then base, and then collector. So in particular, this PNP type, the current divides, or the current gets divided, while in NPN transistor the current gets combined. Now let's just see the operation. Now the emitter of NPN divides is made of N type of material, and hence the majority charge carriers are electrons. When base emitter junction is forward bias. See, look here, the condition is forward bias. When the base emitter junction, so a junction as base and emitter, in particular NPN type I am talking about. In NPN transistor, the emitter, or you can say the emitter part, is highly is N type of material, and it will have a higher amount of electrons. And whenever this type is forward biased, this PN junction, base and emitter, this base and emitter would be in forward bias. Forward bias means what? Means it has more electrons, means the negativity over here is higher, because it is a N type, and because it is a P type, there will be positive charge carrier, or you can say electrons holes will be major and in majority. So how can you forward bias it, or you can connect it in forward bias by connecting the negative of battery to emitter. So when condition is when and only when the base emitter junction, this base emitter junction is forward bias, means battery's negative terminal is connected to emitter and battery is positive to base. As forward bias, the electrons will move from n-type region towards the p-type region and minority charge carrier moves towards the n-type of region. So conduction happens in here. When they meet each other, they will combine, enabling a current to flow across the junction. So whenever they combines, and the combining procedure, or you can say the combining process, offers a current to flow across the junction. When the junction is reversed bias, in case of reverse biasing the transistor. So when the transistor is reversed bias, the holes and electrons move away from each other, and there will be a depletion region between the two areas, and there will be no current flow. And hence, in forward bias, there would be a current flow, and in reverse bias there will be no flow of current. The same principle is used for PNP transistors, except the current carriers are holes and the voltages are reversed. So this is how the NPN transistor working is explained. The base emitter, here is, this is emitter junction, this is collector junction, so this is collector, this is emitter, and this emitter and base. This PN junction is forward biased, means the emitter is connected to negative terminal of battery and this base is connected to positive terminal of battery, hence it is forward biased, and hence the electrons from n type goes to the holes, or it attracts towards the holes of this region, and this combining of these two carriers enables the current flow through the PN junction, and this is how the current flows in in a specific NPN transistor. Now let's talk about FET. Now FET stands for field effect transistor. Now this field effect transistors have three terminals, namely gate, source and drain. The voltage at the gate terminal can control a current between source and drain. So in this type of transistor, the voltage at gate terminal controls a current between source and drain. Field effect transistor is unipolar transistor. So the BJTs were bipolar transistors while FETs are unipolar transistors, in which N-channel FET or P-channel FET are used for conduction. So particular N-channel is used for conduction, and the particular separate p channel is used for conduction. In BJTs, p and junction, means p and n, both junctions are used for conduction, while in this type n channel FET and p channel FET, they are separately used for conduction. The main applications of FETs are in low noise amplifiers, buffer amplifiers and analog switch. So this is how a schematic representation of FET is done. In FET, there are two terminals, namely gate, drain and source. This is N channel. The signal or current coming towards gate. This is N channel, and the signal or means voltage or current going out of the gate, it is P channel. The FETs has two types, namely JFET and MOSFET. So first is JFET, which is junction field effect transistor. So these are also three-lead semiconductor devices, and they are used as electrically controlled switches, current amplifiers and voltage controlled resistors. Unlike BJTs, JFETs do not require a bias current and are controlled by using only voltage. So these are the transistors which are controlled using only voltage. JFTs are normally on when VG minus VS means voltage at gain and voltage at source is the difference of both is zero. So they are normally on. When a VG minus VS doesn't equal to zero, then JFETs become resistance to current flow through the drain source pair, which are JFTs are depletion device. So there are two further types, N channel and P channel. A negative voltage applied at its gate means VG is less than VS, reduces current flow from drain to source. While a positive voltage applied at gate means voltage at gate is higher than voltage at source. Then it reduces current flowing from source to drain and it operates with V as greater than BD. So this is how JFET looks like. In JFET, there are also three terminals: gate, drain and source. Here, this is drain, this is source and this is gate. Now let's see the MOSFETs. So MOSFET stands for metal oxide semiconductor field effect transistors. So these are the widely used transistors till date. Means their application area is so wide that they are so popular and hence they are manufactured in billions and trillions of amount, most commonly fabricated by the controlled oxidation of silicon. So they are commonly fabricated by controlled oxidation of silicon. It has an insulated gate, the voltage of which determines the conductivity of device. So this type of transistors has an insulated gate and the voltage of this gate determines the conductivity of device. A metal oxide insulator is placed at the gate to obtain high input impedance at the gate. So a metal oxide insulator is used for what? Is used for high input impedance at the gate. Now gate input impedance is approximately is equals to 1014 ohm. This is higher impedance. And these MOSFETs are further classified into enhancement type and depletion type. Now, the main advantage of MOSFET is that it requires almost no current. These type of metal oxide semiconductor field effect transistors requires no input current to control the load current when compared with BJTs. So in comparison to BJTs, they require no current to control the load current, means at specifically no zero input current they are able to control the current at load side. In enhancement mode, the voltage applied to the gate terminal increases the conductivity of the device. Enhancement name itself suggests that it increasing something, means in enhancement type of MOSFETs, the voltage at gate terminal, the voltage applied to gate terminal, it increases the conductivity of device. While in depletion mode, the voltage applied at gate reduces the conductivity. Means your conductivity depends upon the gate's conductivity. If you have given the voltage and it increases the conductivity, means they are enhancement type. And if voltage applied at gate reduces its conductivity, then they are depletion mode transistor. This is how a schematic diagram represented for MOSFETs. In MOSFETs, there is a metal partially metal surface. Here is a resin case, and this is particularly TO220 transistor. First, second, third, these are the three terminals. The first is gate, the second is drain, and third is source. So this is how its internal diagram is represented. This is a Zener diode, this is a normal diode, and due to this kind of replacement of diode gives enhancement and different depletion type of MOSFETs. The third part of this section or session of transistors is the different characteristics of transistors. So in this section, we will see the different characteristics which are input, output and current transfer characteristics of a transistors. So first of all, what is a characteristics? So these characteristics of transistors are determined by the transistors constructions and the type of semiconductor material used in the manufacturing of that particular transistors. So these all characteristics are determined, or you can say dependent on the type of material, semiconductor material used in the manufacturing of transistors, and also how it is constructed. So, the characteristics are divided into three types, which is input characteristics, output characteristics, and current transfer characteristics. So, what are input characteristics? So, this input characteristics will give us the details about the change in input current. It is input characteristics, hence, it gives us details about the change in input current with the variation in input voltage. So change in input voltage with the variation in input voltage by keeping output voltage constant. So in input characteristics, we will keep the output voltage constant and we will see the changes that occurs in input current by changing the input voltage. Now output characteristics. So the output characteristics is nothing but it is a graph or plot of output current with output voltage. So it is a graph of output current versus output voltage, and at this time you will have to keep the input current constant. So when you are measuring, or when you can say it is output characteristics, so you are measuring or you are plotting a graph of output current versus output voltage, keeping or at the input voltage constant. So these are nothing but the output characteristics. Now the current transfer characteristics. So this type of characteristics are the plot or graph that shows the variation of output current. Variation in output current with change in input current by keeping the input voltage constant. So in this particular type, we have to keep the input voltage constant to see the variation of output current with input current. So this is the graph between the variation of output current versus the input current by keeping the input voltage constant. Now there are different configurations onto which these characteristics are developed, and depending upon the configuration used to form typical transistors, the application of that transistor differs. So there are three different configurations which are used while making a transistors. First one is a common emitter, means CE. This is a CE configuration. In CE configuration, what would happen in this kind of CE, means common emitter? In common emitter configuration, the emitter of that particular transistor will be common terminal for both input and output circuit. Now, in common base configuration or common base type of transistors, what would happen? The base terminal is a common terminal for both input and output circuit. And similarly for CC configuration or CC type of transistors, the collector terminal would behave as a common terminal for both input and output circuit. So depending upon the configuration, the way the applications of the transistors changes. Now first we will see the input characteristics of these three different types of configurations. So for CB configuration, so here in input characteristics you are seeing the input voltage. So here IE versus VBE graph is plotted and the voltage's value is measured, which is common base. This is for common base configuration. In these, the base is common for both input and output circuit. Means CB1 means input and CB2 for output. So this is how the voltage varies, and this is the representation of this with IE means the emitter current, input current and input voltage. VBE. This chart will describe the variation of emitter current, means change in emitter current IE with base emitter voltage VBE and keeping the collector voltage constant at constant collector voltage. Now the second is CC configuration, means common collector configuration. In common collector configuration, there is a plot or a graph between IB and VCB, means it shows the variation in base current with the change in base collector current voltage by keeping the VCE means the collector emitter voltage at constant. This is the graph or characteristic representation for common emitter configuration. So in this particular type, it shows the variation in base current IB versus VBE. So change in base current with voltage at base emitter by keeping the VCE constant. So we are keeping the voltage VCE as constant in throughout this input characteristic in CB, CC and CE configuration. Now let's see the output characteristics of this three configurations CB, CC and CE. So in CB configuration means common base configuration, it shows the collector current means IC with VCB voltage at common collector and base collector base voltage by keeping the emitter current constant. So here we are keeping the emitter current as constant, and we are seeing or we are noticing the change in the collector current by changing the value of voltage at collector and base terminal. This is the representation for common collector configuration. In this type, we are seeing or noticing the variation in the emitter current by keeping IB constant, means the value of base current we are keeping constant for this configuration, and we are noticing the change in emitter current with the voltage at collector and emitter. Now let's see the CE configuration. Means in this type of configuration, the emitter is common for both input and output circuit, and here it shows the variation in IC, means the graph is showing the variation in collector current with the change in voltage at collector emitter by keeping the IB constant, means we are here keeping the current at base as a constant and how it changes or how the collector current changes with change in voltage at collector emitter junction. In this configuration, the transistor's emitter is common for both input and output circuits. The transistor's base voltage controls the transistor's current gain. Here, the transistor's base voltage means the voltage at transistor's base controls the transistor's current, making the CE means this common emitter configuration ideal for amplifier circuits. So this common emitter configuration is generally used for amplifying circuits or used in amplifier circuits because of the reason that the base voltage controls the transistor's current gain, means voltage at base controls the transistor's current gain. Now, there are two types of output characteristics, and the output characteristics are majorly used to determine the current gain, and hence they are used to perform several tasks. So, there are two different types of output characteristics which are linear and non-linear. In linear output characteristics, what happens that, or you can say it is called as linear output characteristics, where the transistor's output is proportional to transistor's input voltage. So whenever the transistor's output voltage is proportional to transistor's input voltage, then you can say it is a linear output configuration or characteristics. While in non-linear output characteristics, what happens that the transistor's output is not proportional to transistor's input voltage, and hence it is named as non-linear. So this particular common ammeter configuration, CE configuration, is used in amplifier circuits. Now, the transistors has three different operating regions, namely active region, saturation region, and cutoff region. So the you can say your transistor always operates in three different regions. First is active region. In this region, or you can say it is the area on the output curve where the output current is almost constant and independent of output voltage. Means it is the area in which the output current does not depends upon the output voltage and it is almost constant. So that area of your curve, output curve, in which your output current is almost constant, so it becomes independent, it becomes independent of its output voltage, so it does not depend upon output voltage, and it is almost, after then it is almost constant, and hence it is called as active region. The transistor operates in active region if the base resistance is greater than the maximum value allowed, and a transistor can only be used as an amplifier if it is in the active region. So if you want to use a transistor as an amplifier, you need to operate or conduct it in active region, providing the emitter junction in forward bias and collector junction in reverse bias. So whenever you have to operate a transistor or use a transistor as amplifier, you will have to keep it in active region, or you will have to operate in active region. And also the condition for it is that emitter region should be in forward bias and the collector junction should be in the reverse bias for the operation of active region. So in active region, the output current is almost becomes constant and independent of output voltage. Now second is saturation region. It is the area where the collector current rapidly increases with a little increase in output voltage. So in saturation region, what happens that a small change or small increase in output voltage gives collector current rapid increase. Means small change in output or a small increase in our output voltage gives a rapid increase of collector current. The base resistance should be less than the maximum allowed value to run the transistor in saturation region. So to operate a transistor In a saturation region, the base resistance should be less than the maximum allowed value. While to operate a transistor in active region, the base resistance should be greater than. So whenever the base resistance is greater than maximum allowed value, it can operate in active region, while keeping the base resistance value lower or lesser than the maximum allowed value, you can operate in a saturation region. Both emitter and collector junctions should be in forward bias for a saturation region. So in order to operate a transistor in saturation region, the both emitter and collector junction should be in forward bias region only. The transistor works like an on stage of a switch in a saturation zone. So in saturation zone, what happens that it operates at on switch, means it is a switching operation of transistor. By keeping it in a saturation region, it behaves like a on switch. And what happens in cutoff region is the base current is effectively zero. In this cutoff region, the base current is effectively zero. As a result, even at higher output voltage, collector current becomes zero. So, as we discussed earlier, to turn on the transistor, you have to have some amount of base current. But when base current is effectively zero, then no amount of output voltage can create collector current, and hence the collector current becomes zero. To operate a transistor in the cutoff region, both the emitter and collector junctions must be in reversed biased condition. So as I discussed earlier, that in the forward biasing region, means keeping the emitter region in forward bias, you can operate or turn on your transistor, and reverse biasing them will give you a transistor in off state. So that action, that to operate a transistor in cutoff region, the both the emitter and collector junctions must be in reversed bias condition. A transistor operates like off stage of a switch in a cutoff region. So in cutoff region, what happens is that your transistor behaves like an off stage in a switch. So saturation region performs an on stage of a switch, while a cutoff region behaves like off stage of a switch. And in cutoff region, or you can say to operate your transistor in cutoff region, the emitter and the collector junctions must be in reverse bias condition, and hence the base current is effectively zero. There would be no flow of current. Now let's see the current transfer characteristics of transistors. So current transfer characteristics for a particular CB configuration, or you can say the common base configuration, looks something like this. It gives variation of IC, means it gives you graph or plot between the col- uh, collector current and emitter current, while keeping your voltage at base common array collector base current constant. So when you keep VCB constant, then the graph for IC versus IE gives you current transfer characteristics for particular CB configuration. Now for CC, means common collector configuration. Now common collector configuration happens when you plot a graph of IE versus IB, keeping your collector emitter voltage constant. So it gives you variation in emitter current with change in base current, while keeping your collector emitter current as a constant quantity. So this is how CC configuration for current transfer characteristics looks like. Now in common emitter configuration, what happens is while keeping the collector emitter voltage constant, it gives you graph of change in IC with change in IB, while a collector current and base current. So here it shows the variation of IC with IB by keeping VCE constant. Let's see the fourth and last part of our today's transistor session, which is applications, advantages and disadvantages of them. So let's first see its applications. So application of transistor as a switch. So as we have discussed earlier that you can use a transistor as a switch, means you can replace this transistor as an electronic switch. So in the particular switch section or session, our previous lectures about switches, in that we have seen a transistor. So transistor is also an electronic switch. So you can use them to turn on and off the main electrical circuit connected to it by providing a specific voltage or current at base pin. You can turn on the particular device connected to it, and providing or providing zero current or zero voltage or removing the input from its base pin, you can turn off the latter element, or you can say the connected device. So transistors are commonly used in digital circuit as electronic switches, which can be either in on or off operation, both for high power applications such as a switched mode power supplies, and for low power applications such as in logic gates. Important parameters for this application includes the current switched, the voltage handled and the switching speed, means at which speed it operates the switching operation, characterized by the rise and fall times. So this includes these devices, means you can say to turn on LED, means the LED feature is the most widely employed practical application that is used as a switch for the transistor. Also you can operate relay. So a relay operation can be managed by making the necessary circuit changes in order to control and connect some external devices with respect to relay. Also you can connect you can control DC motor and also monitor it through transistor. This is used to turn the engine on and off. The motor speed can be modified by changing the transistor frequency values. So a particular DC motor connected to it, its speed you can vary it by changing the transistor's frequency value. Also, light bulb is also one of these examples. It can switch the light on if the setting is bright and off depending on the dark surrounding. A light dependent resistor is used to do this. Also, a thermistor can be controlled using this switching method, means using the transistor switching method, which detects the ambient temperature. The thermistor is called as a resistor. This resistance increases when temperature sensed is low, and the resistance decreases when the sensed temperature is high. So this is how you can use a transistor as a switch. Now let's see transistors application as an amplifier. So in the previous slides we have seen that transistors, if you provide lower signal or lower input, it can give you a higher output, means it is nothing but a property of amplification, means a weaker signal can transform into a stronger signal using transistor. The common emitter amplifier is designed so that a small change in voltage, means V input, changes the small current through the base of transistor, whose current amplification combined with the properties of circuit means that small swings in V input produces large changes in V output. So specifically the common emitter amplifier are used for the purpose of amplification. In this type of amplifiers, the smaller change in input voltage can produce large change in output voltage. Various configuration of single transistor amplifiers are possible, with some providing current gain, some voltage gain, and some in both. So their application areas are from mobile phones to televisions. Vast number of products includes amplifiers for sound reproduction, radio transmission, and signal processing. So these are the applications of a transistor as an amplifier. Let's see the advantages, that what are the different advantages of a transistor. So first and very basic is their small size and also a low weight. So transistors are very small in size and low in weight, hence the reduced equipment size. Because of their small size and lower weight, they reduces the equipment size. Large number of extremely small transistors can be manufactured as a single integrated circuit. So the large number of them can be used to manufacture as a single integrated circuit. Also low operating voltages. So the transistors has very low operating voltage, as we discussed earlier, that it requires zero point 0.6 to zero point 0.7 volt to at base point or base pin to turn on a transistor. So they have low operating voltage. Very low sensitivity to mechanical shock and vibrations. Means they have not that much sensitivity to mechanical shock and vibration, providing physical roughness and virtually eliminated shock induced superior signals. No cathode heater, means they doesn't require cathode heater, hence reducing power consumptions and eliminating delays as tube heaters warm up and immune from cathode poisoning depletion. So these were some of the advantages of transistors. Now let's see the disadvantages of transistors. They have a higher electron mobility afforded by the vacuum or vacuum tubes, which is desirable for high power, high frequency operations, such as that used in some over the air television transmitters and in traveling waves tubes used as amplifiers in some satellites. Now, the transistors and other solid state drives are sus- uh, susceptible to damage from very brief electrical and thermal events. So, they are sensitive to electrical and thermal events, including electrostatic change, discharge in handling. Vacuum tubes are electrically much more rugged compared to these transistors. Now, these transistors are sensitive to radiation and cosmic rays. This is the disadvantage. Special radiation hardened chips are used for spacecraft devices, and also in audio applications. The transistors lack lower harmonic distortions, the so-called tube sound, which is characteristic of vacuum tubes and is preferred by some of them. So this was all about transistors and their working, advantages, disadvantages, different types. We will see you in the next tutorial.